Hello everyone, this is Manik Marupal of CSIT section. Today's my tech talk topic in disaster management is power from waste. The hidden crisis, disaster waste overwhelming communities. Natural and human-made disasters generate massive quantities of debris that threaten public health, contaminate environments, and severely impede recovery efforts. Post-disaster waste often includes hazardous materials, so asbestos, pesticides, and untreated debris that block access routes and contaminate vital waterways. Improper disposal practices risk long-term environmental damage, delay reconstruction timelines, and compound suffering of affected communities. The secondary disaster of unmanaged waste demands urgent, innovative ideas. When waste becomes a second disaster, it, the cascading impact. Disaster debris does not just obstruct roads, it creates cascading crises, block emergency routes, delay rescue operations. Contaminated materials leach toxins into soil and water. Mountains of waste overwhelm existing infrastructure and threaten public health for months or years. Without strategic waste management, communities face prolonged displacements, economic statistics, and environmental degradation of compound the original of state, turning waste into opportunity. The waste management hierarchy: reuse, recycle, recovery and disposal, source reduction, extend product life, recover materials, and recovery and disposal, energy recovery, treatment and disposal, prevent waste generation at the source. The Environmental Protection Agency prioritizes source reduction, reuse, recycling, and composting. Before considering disposal, pre-incident planning pros, critical codes, and comprehensive debris management plan significantly reduce both waste volume and toxicity. Waste to energy, transforming rubbish into power. The WTE process means waste to energy process. Waste to energy technology converts non-hazardous disaster and municipal waste into electricity and heat, dramatically reducing landfill dependency and harmful emissions, which leads generating clean power. Two core technologies they are incineration. Incineration uses controlled combination to generate steam for electricity, and gasification applies high heat with limited oxygen to produce snake gas, a versatile fuel for power generation. Environmental safety. Modern WTE plants employ advanced pollution control systems, including scrubbers, filters, and continuous emissions monitoring to minimize harmful releases and exceed release gases like standard gases. Case study: the Gen system, small scale, on site recovery, power generation, rapid deployment, circular and economy, power generation. Converts waste from 20,000 people into zero point 0.3 milliwatt clean electricity, enough to power 130 homes or provide basic services for 6,000 individuals in crisis situations. Rapid deployment, ideal for remote or disaster affected areas, the system accelerates debris clearance, wishlist, dramatically reducing transport, logistics, and landfill costs through on-site processing. Circular economy transforms combustible plastics, fabrics, constructions, valuable energy supports economy principle and re- resi- resilience simultaneously. Environmental and economic benefits of waste to energy, environmental protection, job creation, renewable energy, material recovery. Environmental protection, it means diverts thousands of tons of landfills, reducing methane emissions and con- conserving precious landfill capacity for decades. Renewable energy provides reliable renewable power supporting local grid resilience and reducing dependency on fossil fuels. Job creation creates skilled employment in plant operation, maintenance, energy engineering, and waste logistics, supporting local economies. Material recovery enable recovery for metals and other valuable things that creates energy extractions, closing resource loops, and every waste material. Challenges and considerations. Regulatory oversight, investment and engagement, waste segregation. Strict regulatory framework essential to control air emissions, monitoring environmental impacts, and ensure hazardous waste streams are properly excluded from processing. Investment and engagement. Significant upfront capital investment requires alongside sustainable community engagement to build trust, address concerns, and ensure successful WTE waste to energy integration into local infrastructure. Waste segregation, effective waste segregation and pre-sorting prove critical to environmental safety, operational efficiency, and maximizing energy recovery, which is protecting equipment and minimizing emissions. Building resilient communities through waste management. A strategic approach to recovery, systematic planning, and targeted waste management dramatically improves recovery speed, protect community health, and build long-term resilience. Innovative models integrate disaster waste management with resilience theory and network governance framework for superior outcomes. Internal guidelines emphasizes minimizing risk, maximizing recovery value from debris, and providing essential support to affected populations during their most vulnerable moments. Effective waste management is not just about clearing debris, it's about transforming crisis into opportunity, protecting the environment, and powering recovery. Key takeaways from crisis to clean energy. 1. Plan before disaster strikes. 2. Implement the waste hierarchy. 3. Deploy waste to energy solutions. 4. Ensure environmental safety. Plan before disaster strikes. Pre-incident debris management plans, resilient building codes, and waste reduction strategies minimize post-disaster challenges. Implement the waste hierarchy. Prioritize reduction, use, reuse, and recycling before considering energy recovery or disposal to maximize resource value. Deploy waste to energy solutions. Transform disaster debris into clean power, reducing landfill burden, wish list, supporting community recovery and resilience. Ensure environmental safety. Maintain strict regulatory oversight, proper waste segregation, and advanced pollution controls to protect public health and ecosystems. Thank you.